Hi YouTube. In this video I diagnosed and repaired a TDK A360 Bluetooth speaker. It wasn't powering on, and throughout this video I systematically figured out what the issue was. As you will see, the issue is sometimes easier than you think it is, but it's sometimes difficult to find. It turned out to be a bad power jack that had a brittle negative terminal. What made it difficult to diagnose was that there was a voltage measured at the jack but eventually became inconsistent. If the terminal had not fallen out, I would have never figured out what the problem was. This video is longer than the videos I usually post, but I wanted to show what I did to diagnose the issue and how I fixed the issue. The first thing I did was smack the power button a few times to confirm that the speaker wasn't powering on. Next, I accessed the battery panel, of course by first using the incorrect screwdriver, and then switched to a Torx screwdriver to remove the access panel. Then I took a multimeter and measured the red and black wires, and the voltage was low, indicating that either the battery wasn't being charged properly or wouldn't hold a charge. Since the speaker didn't have any power, let's assume for now that there's something wrong with the speaker and not the battery. Now let's check and see if the charger will charge the speaker. Before taking the speaker apart, let's see if the charger itself works. And as you can see, the charger is correctly outputting 19 volts. Plug the charger into the speaker, slap the power button a few more times, and see that it's still not working. So on to the fun part, taking the speaker apart. I'm not going to go into details on taking the speaker apart, but take note at how much manufacturers seal the speaker for water resistance. It sure does make taking the speaker more difficult to take apart, but I'm glad they went through the effort to weather seal the speaker as good as possible. As a reminder, once you take speakers like this apart, it will more than likely lose a good bit if not all of its water resistance, so be careful using the speaker around water if it has been repaired. With the base removed, let's do some probing and see if we can find something wrong with the wiring. Here I have the multimeter set to continuity mode, and I'm checking to see if there's continuity between the power jack and the plug where the jack is plugged into the speaker's circuit board. Since there doesn't seem to be any issues, let's take the circuit board out and see if there's anything obviously wrong with it. Remember that I mentioned the power jack is in fact bad? This is one of the cases where everything seems to be fine, but in fact the power jack is broken. Here I removed the battery to see if there is something wrong with the battery section of the speaker. As you can see, the battery is glued in very well and needed to be pried out. Be careful when prying, especially when using a metal object. Make sure the battery isn't punctured, otherwise you may be in for a nasty surprise. You've been warned. Let's plug the battery and charger back in and measure voltages at the board. I found out that the voltage fluctuated, and it seemed to me like there was a loose connection somewhere, so I decided to access the power jack and see if there's anything wrong with it. The circuit board contains the power jack, and of course they sealed the bejesus out of it, so as you can see I'm struggling to get it out. With some prying and cutting I managed to get the stupid thing out. And this is the eureka moment where I do a closer visual inspection of the power jack and see that the negative terminal tab is brittle and broken. Luckily I have power jacks and check and see if a 2.1 or 2.5mm barrel power jack works. It looks like the 2.1mm jack is the winner here. In order to replace the jack, you're going to need a soldering iron, solder, and desoldering braid. It seems counterintuitive, but I first apply solder to the joint. Use a flathead screwdriver to apply pressure between the board and jack while heating up the solder to remove the power jack. Adding solder in the beginning aids in removing the power jack more easily. Solder flux helps as well, but I didn't have any at the time while I was doing the repair. After the power jack has been successfully removed, use desoldering braid to suck up all the old solder. Unfortunately, I couldn't find mine, so I heated up the solder while pushing the jack into place. After placing the jack into place, I applied more solder to ensure a good solder joint, resulting in a good connection. The best advice I can give you if you're new to soldering is to heat the solder pad on the board and the solder leg on the power jack simultaneously, and then applying solder to ensure a good connection. As you can see here, out of curiosity, I looked into the old power jack and confirmed that the power jack was indeed bad. I also tested to make sure there was proper continuity between the power jack and the connector, and then started reassembling the speaker back together. After partially assembling it, I tested to see if the speaker worked. And voila, it works.
Every time we say goodbye, they all see that it's a lie. 'Cause we always give it one last try. Yeah, you've watched me break 1,000 times. Now I'm all alone, 'cause you never show. You say you will, but then you don't.
Let's finish assembling it so that we can test all functionality and make sure everything is working as expected. Wait, not so fast. As with other Bluetooth speakers, if the battery is worn out and has a loss in capacity, music will stop playing when it's turned up too loud. However, it will work with the charger plugged in. I'll replace this in another video, and luckily the speaker uses old school nickel metal hydride batteries, which should make replacement easy. Let's finish final assembly and we're good to go. Luckily all speakers and functionality seems to be in order. Did you guys enjoy this content and prefer the style of this video? Comment below. Like, share, subscribe, and I'll see you in the next video. Thanks for watching.